Hello, welcome to our channel. In this video, we will talk about composition of functions. We will look at the definition of composition of functions, and we will look at the examples. Basically, composition of two functions is just like applying two functions in a row to an input. We can consider functions as machines. So for the first function g, we input x, it will output g of x. We run it through this machine G, and then we take that output and make it an input for the second function f. So since input is g of x here, if you run it through f, then the output would be f of g of x. So this would be the overall output. So to input x, the overall output is f of g of x. So this we call composition of f and g. If we want to look at it in terms of arrow diagram, we have one set here that contains the initial input x, another set here, and another set here. So function g will take this x to g of x, some number g of x, and then we can apply function f to this g of x. So that will give us f of g of x. So this overall from x to f of g of x is the composition. So basically it's just applying two functions in a row. So if we look at this example, let's look at a definite example. Let's say we have g of x defined as x squared, the squaring function, and we can say f of x is x plus 1. So let's say if you input 2, value of x is 2, then your output would be 4, and then you take it as input for the second function. And then your output will be 4 plus 1 over here, 5. So when we apply f and g in a row like this, the input 2 becomes output 5. Again, composition is just applying two functions in a row, one after another. So we can say f of g of 2 is 5. And this we can write as f of g of 2, which is 5. So this is the notation we use for composition of two functions. So we will put that more formally. So composition of two functions, f and g, f of g. So we read this as f of g of x is f of g of x. And so here we have an example. Suppose f of x is square root of x plus 1 and g of x is 2x minus 3. We want to find the following. So first you want to find f of g of x. So using the definition, f of g of x is simply f of g of x, like that. So this means f of, so g of x, we first do the inside here, g of x is 2x minus 3. So now f of x is x square root of x plus 1. So we replace that x with 2x minus 3. So it becomes square root of 2x minus 3 plus 1. So this is the composition f of g of x. We can simplify this little further to make it square root of 2x minus 2. Next, we want to find g of f of x. So this will be g of f of x. And f of x is given to be square root of x plus 1. So we can replace this f of x with square root of x plus 1. Since g of x is 2x minus 3, we want to find g of square root of x plus 1. So if we replace that x with square root of x plus 1, we want to do the same thing to that x as well. So 2 square root of x plus 1 minus 3. So this is the composition g of f of x. Next, we want to find f of x. So we can compose a function with itself. So it will look like f of x. So f of x is square root of x plus 1. So we can replace this inside f of x with square root of x plus 1. And then we have square root of, so we replace x, this input, with square root of x plus 1. So we need to do the same thing over here also. So square root of x plus 1 plus 1. So this is the composition f of x. Right, so next we need to find f of g of 6. So this will be f of g of 6. Now g of 6 is simply you plug in the value of 6 over here. So 2 times 6 minus 3, which is 12 minus 3, which is 9, g of 9. And f of 9, you plug in value of x over here. So 9 plus 1, which is square root of 10. Or we could simply use this expression over here, since we have already evaluated the expression for f of g. So we could just say f of g of 6 is simply 2 times 6 minus 2, using that one. So which is again square root of 10. Because 2 times 6 is 12, minus 2 is 10. Next, we want to find g of f of 6. So this would be g of f of 6. This will be g of f of 6 is square root of 6 plus 1. So square root of 7. And then we plug in square root of 7 for x in the function g. So that will give us 2 square root of 7 minus 3. So this is g of f of 6. Or like we did with number 4, we can use this expression for g of f. So we get g of f of 6 equals 2 times square root of 6 plus 1 minus 3, which is exactly what we got over here. So 2 square root of 7 minus 3. Here is another example. Here we are given a table of values and we want to find these compositions. So first we want to find f of g of 1. So this is simply f of g of 1. So g of 1 is the value of function g when x is 1. So we are looking at that column. X is 1 over here and value of g is negative 3. So g of 1 is negative 3. And now we are looking at f of negative 3. So x value is negative 3 now. And f of negative 3 is 5. So this composition is 5. Next, we want to find g of f of 1. So which is g of f of 1. F of 1 is 1. When x is 1, function f is 1. And g of 1 is negative 3. The last one here, we want to find g of 2, which we can write like this. So g of 2 is 3. When x is 2, function g is 3. So g of 2 is 3. Now we want to find g of 3. So when x is 3, function g is 4. So this would be 4. G of 3 is 4. Here is another example. Here we are given two graphs, K and L, and we want to find these compositions of K and L. So K of L of 0 is K of L of 0. We can write this way. L of 0 is negative 7. So K of negative 7. So we need to look for value of k when x is -7. X is -7 is outside this graph, and the graph of k doesn't go beyond -4, x equals -4. So this is outside the domain. That means this 0 is not in domain of the composition. This is undefined because this is outside the domain. Now let's try the second one, L of k of -1. So here we write this as L of k of -1. K of -1 is -4. When x is -1, the y value on the graph of k is -4. We are looking at L of -4. Again, L of -4 is not defined. See, the graph of L goes only up to -1, x equals -1. So this is also undefined. So again, this -1 is not in domain. So for composition, we have to be very careful about domain. So again, this -1 is not in domain of L of k. Next, let's look at L of k of 9.5. So this we can write as L of k of 9.5, which is L of, so k of 9.5. 9.5 is right here. Well, here, 9.5 is here. So 9.5 is right here. And looks like the y value on the graph of k is 0. So we are looking at L of 0, which is, now when x is 0, L is -7. So this is -7. The last one, k of 9. K of 9 is 2 over here. So we can, well, we can first write this as k of 9. We see k of 9 is 2. The y value on the graph of k when x is 9 is 2. And now we look at k of 2. When x value is 2, the y value on the graph of k is -1. So this is -1. So this composition is -1. So we are done with these problems. And this is all I have put together in this video. Thank you for watching. See you in our next videos.